Hey everyone, in this video we are going to see how to write the Verilog code for 2:1 MUX using else if statement. So we know that 2:1 MUX is having two inputs D0 and D1 and it has got a select line S. So if the value of select line S is equal to 0, at that time the output will be D0, and if its value is equal to 1, at that time the output will be equal to D1. So here the enable bar is the active low pin. So if enable bar value is equal to 0, at that time the MUX will be operational, and if the enable bar value is equal to 1, at that time it will be in the inactive state. So that's the meaning of active low. So at the 0 the MUX will be on, and if it is 1 the MUX will be off. Okay, so this shows the truth table for the MUX. So enable bar yes and y. So y is the output here. So if enable bar is 0, that is active low, and s is value is 0, so at that time d0 will be the output. And if enable bar is 0 and s is equal to 1, at that time the output will be d1. So if the enable bar value becomes 1, at that time instead of so it will not bother about the value of s, because although the enable bar value has become 0, so at that time it will however the output will be equal to 0, because the MUX will be in the off state itself. So like this MUX that is 2:1 MUX works. Okay, so how I can write the code for this one, let us see. So that is Verilog code we are writing. So module MUX v2, so this is the user defined name which I can give. So I have given it as MUX, and V for Verilog, 2 is for 2:1 MUX. Okay, so we have to write input and output parameters in the bracket here. So D0, D1, S are the inputs and enable bar is input. So Y is the output here. So what are all input output pins we are using in the design, we should mention here. Okay, so then specify what are the inputs and what are the outputs. So input D0, input D1, input S, and input enable bar. So these are all inputs and they should be ended with a semicolon here. And output Y. So Y is the output here, so I will write output Y. So this is one section. Then you have to write always at. So this will be taking these variables, that is the input output terms. So D0, D1, yes, and enable bar. So input variables we have to write here. So D0, D1, yes, and the enable bar. So for this always we will be having a begin. So in begin we are using a else if statement. So if so in bracket we have to write the condition enable bar double equal to 0. So this means enable bar value is equal to 0, and so this is the logical, and yes value is equal to 0. So double, so note that we should be only using the double equal to here. So at that moment so for this if we will be having a begin. So in Verilog we will be having, if for each and every loop we will be having a begin and the end. So begin assign y equal to d0. So for 0 0 condition the y value is d0 here. So that's I have written 0 0 y value will be d0. So for this begin this will be the end, and for if we will be having a else if here. So else if enable bar value is equal to 0 and s value is equal to 1, that is this condition 0 and 1, at that time for else if we will be having a begin and assign y equal to d1 and end this begin. Okay, so this we have completed these two conditions here. So what will happen if enable bar value is equal to 1? So for this if I will be writing a direct else condition here. So that means enable bar value is not equal to 0 here for this condition. At that moment, as I already said, the output will be directly equal to 0. So y will be assigned equal to 0 here. So this will be the end of the begin here. So this if is ended here. So and this module will be ended here. So this begin and this end. So this begin and this end will be closing to each other. Then end module means this MUX v2 which we have opened here, it will be end. So anything which is below this end module will be not executed by the Xilinx model sim, because it will assume that this is the end of program and others is the comment or something else which is not relevant for execution. So whatever you write within this end module, so that it will be considered by the compiler at the time of compilation. So as well as the runtime machine. Okay, So this is how we can write a simple Verilog code for 2:1 mux using an else if statement. So where we will be continuously checking the conditions according to the truth table. So I hope you like this video. Please guys, if you are new to the channel, hit the like button and subscribe the channel for more updates. Thank you. Thanks for watching.